Today we're going to talk about area, perimeter, circumference of some basic polygons and also of circles. It's important to remember in this unit that we're doing, Unit 4, we have to worry about formulas. So we do need to memorize these formulas for our different geometric figures. Perimeter is pretty easy because we're going to use one basic formula to do all of these. So what we're going to do for all of these is just write sum of sides. So this is what so whenever we have perimeter, we're going to say that P equals sum of sides. When I taught 6th grade, my 6th graders actually started saying P equals SOS for sum of sides. So that's another way you can be thinking about it. That it's going to be sum of all sides. Now for your area formulas, you are going to have to memorize a couple of different formulas for that. They're not hard. We've worked with them for a lot since 6th grade, 7th grade, and now again in 8th grade. Excuse me. So for triangles, the hardest thing about triangles is that we have lots of different looks to triangles. You'll notice I try to recreate a bunch of them here. This here would be an equilateral triangle. All those sides are the same. Here is an isosceles triangle, or excuse me, a scaling triangle with one of your angles greater than 90 degrees. So the height is actually on the outside of the triangle. This would be an isosceles triangle here. And then this here would be a right triangle. Another thing to keep in mind is when you're looking at these triangles is that they are always sort of moving around in space. So they are not necessarily sitting on their base, let's say, which a lot of people try to look at it that way and say, oh, then the base has to be the lowest part. For example, on this right triangle, sometimes people say that this is the base, when that's not true. Remember that the height and the base are perpendicular to each other. So whenever you see a right angle, or if you see that dotted line type of thing for the height, that's going to help you to figure out what the height is for the for any triangle that you're given. So perimeter again would just be adding up all the sides. So we would always start with a formula: P equals side plus side plus side, because we have 3 sides on a triangle. So let's say that this was 3 inches, and this is 3 inches, and this is 5 inches. Then I'm just going to go ahead and plug it in. So P equals 3 plus 3 plus 5. And then I'm just going to add it all up. So 3 plus 3 is 6, and 6 plus 5 is 11. So we're going to call this 11 units. This is just because we don't know what the measurement is, so we're always going to just call it a unit if we don't know what the unit is. Now to find the area of a triangle, we have 2 different ways we can do this. One of the way I always do it is I say the area is equal to half BH, which is base times height. So if we're looking at this, I'm going to use that same right triangle that we just did. So that means that I have area is equal to half times the base, which is 3. Now remember, the base is this right here, or it could be this right here. Because on a right triangle, the height and the base, again, are perpendicular to each other. So one of them is the height and one of them is the base. It doesn't really matter which one. And also it doesn't matter because in this case, they're both 3. But if it had been different measurements, it still doesn't matter as long as you designate one the height and one the base. The one thing that cannot be a height or a base is this side right here. That is not a height or a base because that's your hypotenuse on the other side. We'll talk about that later on. So we have a base of 3 and we have a height of 3. Now, I do this 2 ways when I get to this next part. I either do half of one of the numbers and then multiply it by the second number, or I actually will multiply this out and then do it and cut it in half. And since 3 is an odd number and not easy to cut in half, I'm going to go ahead and multiply it first. So 3 times 3 is 9. And then I'm going to say in my head half of 9 is 4.5. So this is 4.5, again, units. Now this time we have to remember we're talking about area. Remember the area goes inside. So we're covering everything inside of the triangle. That means it's my unit squared. Whenever we're talking about area, the unit is always going to be squared. Whenever we're talking about perimeter, it's just going to be the unit. So this is unit squared. Now the other way I can do this, some people prefer to do it this way, is they say that area is equal to BH divided by 2, which is kind of what I did, the way I multiplied the 3 times 3 first, but some people actually like to write the formula this way. In which case then we have area is equal to 3 times 3 divided by 2, and therefore we still get 9 divided by 2, which is 4.5 units. The key thing with these problems, oh, squared, don't forget your squared. The key thing, ladies and gentlemen, with these problems is make sure that you are using the formula and then plugging in your numbers and then solving. That's what's really important as you do these problems. Oops, went a little too far. So our next one here is a square. Squares are pretty easy because, again, our formula for perimeter is our sum of all sides. So P equals sum of sides. This time I have 4 sides to a square. 1, 2, 3, 4. The other thing is on a square, a lot of times they're just going to give you one measurement. So let's say they give you this right here, and they won't tell you anything else. So they'll tell you it's a square, and then you know, or you have to remember, that a square has all sides the same. So whether you look at the square straight on the way this one here is, square number 1, or whether you look at it sort of at an angle like square number 2, they are still a square. It doesn't matter. So all I need to remember is that 5 is my measurement for all my sides. Sometimes it's a good idea. Go ahead and write in the 5 for all the sides so that you know what the measurements are. But we're going to go ahead and put in our 5's up here. So now we have P is equal to 20. This is 20, and again, we're just going to call it units. And remember, because it's perimeter, it's just the units. It's not the unit squared. That's for area. So now we're going to do the area. We have to remember that the formula to find area of a square or a rectangle, which we're going to do in a minute, is length times width. A lot of times you'll see it written kind of cursive. That wasn't very good, but a cursive L. So this time we have 5 times 5. So therefore my area is equal to 25. And again, we're squaring it, so it's units squared. And then this is my answer for my area. Again, rectangles, don't be surprised when you see them looking in different kind of shapes or different ways, not just straightforward like this first one right here. But remember, they're kind of floating around and spinning around in space. You have to think of it that way. So they could be sideways or upside down or however you want to be thinking about it. But do make sure that you're looking at the rectangle all different ways. So again, P is equal to sum of sides. And again, I have 4 sides. 1, 2, 3, 4. So I'm going to make up some measurements here. I'm going to call this 6, and I'm going to call this 4. And then we're going to use this triangle here. So I'm just filling in my blanks with my numbers. So I have 6 and 4. And again, if I have 6 and 4 on one side of my rectangle, the other side is going to be 6, and then that's going to be 4 on the other side of that. So 6 and 4. Doesn't matter how I add these up. I could put 6 and 6 and 4 and 4, however you like to do it. But this way it's pretty easy because 6 and 4 are 10, and then 10 and 10 are 20. So this is 20 units. Happen to be the same as our square. That was just a coincidence. And then again, if I'm going to do the area is still length times width. So area is equal to 6 times 4. And so area is equal to 24 units squared. Again, don't forget that square. The reason why it's squared, if you think about it, is whatever the measurement is for this 6, if this 6, let's say, was centimeters, and whatever this is, if that was 4 centimeters, that means you're going to have centimeters times centimeters, which means you have centimeters squared, which is how we get our units squared. So that's one way to think about it on why it's squared. Parallelogram is actually almost the same as doing a rectangle. It's almost the same thing. What we're going to do here with this is instead of saying area or perimeter is going to be easy enough, like I said, perimeter is still going to be sum of all sides. So again, I still have 4 sides. So let's go ahead and pick some measurements here. Let's call this 10, and let's call this 5. We'll just make it easy numbers. Now again, a parallelogram, opposite sides are congruent, meaning they are the same. So if I'm only given 2 of the sides, I can figure out the other 2 sides still. So I have 10 and 5 and 10 and 5. So 10, 5, 10, 5. That's 15 and 15, which gives me 30 units. Again, not squared because all I'm doing is going around the outside. They're not squaring anything. You're not multiplying. You're just adding more and more and more. So you're just getting more and more centimeters or meters or yards or whatever you're doing. Now with area, it's almost the same thing. We were talking about our square and rectangle being length times width. This is almost the same, only this time we're going to call it a base and a height because we have a base and then we have the height here. Remember, the height's always perpendicular to the base. It gives you a right angle. So I'm going to make this height, let's say this height is 4. So I'm going to use that as the height. So area is equal to base times height. And the reason, again, why it's base times height and not length times width is the fact that there's no width to this because of it being kind of squished over to its side a little bit. It's like you're taking that rectangle and moving the top over and keeping the sides the same and just stretching it. So just make sure you're calling it the right names. It's a base and a height. And also remember that the height comes perpendicular to the base. So the base has to be this 10. It cannot be the 5. 5 is not my base because I don't have a height coming perpendicular to that. So it's not going to be that one. So when I'm looking at this, I have base is 10. So I'm going to put in 10 for the base, and the height we said was 4. And then so my area is equal to 40. And again, it's units squared. So you want to think about that area again being square units. Okay, trapezoids are a bit tricky. One of the first things is to look at the trapezoid itself. You have to remember, again, there's a couple ways to see trapezoids. Basically, remember we're going to have two sides that are parallel. So here's a parallel side to this. And then we're going to have two sides that are not parallel. They're going to be angled in some way. So on this one, we've got our sides that are kind of angled in. This one here, I'll do another color. These sides here are parallel. This green side and this green side, they're parallel. The other two are not. The other thing you have to worry about is the height. Again, remember that the height always comes perpendicular to the base. So we have a height here. This is our height. And either one of these can be called the base. One's going to be called base 1 and one's going to be called base 2. Here again is the height. So again, one of these is going to be base 1. I'm going to call this one base 1 and this one on the bottom base 2. I'm going to use the one that I kind of start on top. We're going to use this one. Let's say that I had measurements here of 6 and then 10 across the bottom. So 6 for base 1 and 10 for base 2. And let's say that my sides are 3 and that my height here is 2. And again, we're just going to call them units at the moment. So if I have all this, now I'm going to find my perimeter. Remember, that part's pretty easy because P is equal to sum of all sides. Again, I have 4 sides, so I'm going to do 4 blanks. The blanks are really just to help you to remember to put 4 numbers in. Because, for example, I have 5 measurements here because the height is in there as well. I don't need the height for my perimeter. Remember, perimeter means I'm literally going to be walking along the outside. So I'm going all the way around the outside of this shape, just like this, if I started right there and ended right there. So I'm just going to add up on my sides. So I'm going to add up 10 plus 3 plus 6 plus 3. When I add it all up, I get 22. And again, units, just units. It's not squared or anything, it's just units. So there's my perimeter. For my area, though, now, this is the hardest one, I think, as far as formulas go. We need to memorize this formula. It's half times the height times B1 plus B2. So this is probably the weirdest formula that you're going to have to memorize. The others all seem to kind of make sense. It's all very similar to like base and height, or like a triangle being half of a square. So it's half of base times height, which makes it kind of easy. The trapezoid here kind of doesn't have anything to help you with. So you just have to kind of memorize it here. But again, I'm going to start with my formula. Always start with your formula. And then I'm going to plug in my numbers. I still have half. My height was 2. My B1, now again, I really can count either one of those as B1, but we've already labeled the top as B1, so that's 6 plus 10 for my B2 down here on the bottom. All right, so I'm going to go ahead and do the parentheses first, order of operations. So I'm going to work that part out first. Half of 2 times 16. Okay, well, here is pretty easy to do. I can do a couple different ways to find half. I can do half of 2, because that's easy. That's just 1. So 1 times 16 is 16. Or I can do half of 16. It's still easy because half of 16 is 8, and then 2 times 8 is 16 again. Or I can actually do the multiplication, 2 times 16, get 32, and then cut it in half. But I think the easiest way is I'm going to do that part first. So area is equal to 1 times 16, which means that area is equal to 16 units squared. And this is what we're talking about right here. So again, I think this formula, just make sure that you are memorizing, well, memorize all the formulas, of course, but make sure you're paying particular close attention to memorizing the formula for that one. Okay, the last thing we have here is circles. Now, circles have a couple of things we need to make sure we know about. So I'm going to tell you some parts of the circle. So make sure you're taking notes on this as well. First of all, the center of the circle is right there. And the center of the circle is what the circle is named as. So if I call this circle K, for example, the dot would be in the middle and the letter K would be there, and then that would be circle K, as opposed to, you know, like on a square, you might have square A, B, C, D, because all the corners have a letter by them. We also need to remember that as we go from here to the edge, this is called a radius. We need to remember, too, that a radius is half the diameter. Speaking of which, then, if I would go all the way straight across, this is a diameter. I'm sorry, my pen isn't writing nice. Oops, and neither am I, apparently. Let's do it again. Diameter. So we have the center, we have the radius, we have a diameter, and then keep in mind that something like this, if you're just going from part of the side of a circle to another part, but not straight across, anything but going straight across, this is called a chord, C-H-O-R-D. Okay, that's a chord. If we have just part of a circle here that's, again, along the edge, but not all the way around or anything, this is called an arc, A-R-C. And then we need to make sure, I should do this another color. If we're going halfway around the circle, all just like so, halfway around and stopping, this is called a semicircle. So make sure you know all those different words, because those are important as we get to working more with circles. Now, we don't have a perimeter of a circle. Instead, we have circumference. So now we do have to memorize a formula. C is equal to pi d, or C is equal to 2 pi r. It depends on how you want to think of it. Personally, I like to use this formula here. I think it's a little easier. You just have two things to worry about, pi and d. And also, you don't get it mixed up with our formula for area. And actually, let me write that one down now while we're thinking about it. Area is equal to pi r squared. But you see, this pi and r and 2 look like this pi and r and 2 here. A lot of people kind of get those mixed up. So personally, I like to use pi d to kind of keep it separate. So I'm going to use pi d for this, and we're going to call our radius, we'll call it 5. Now, one of the things I like to do, too, is I'll say if the radius is 5, that gives me a diameter of 10. And I just like to have that down just in case I'm doing anything with anything at all with radius or diameter. I already have it ready to go, and I don't have to think about it. All right, so C is equal to pi d. That means that C is equal to 3.14 times the diameter. See, this is why I needed the d. The diameter is 10. And then when I multiply that out, is remember, times anything by 10 just means I'm moving the decimal one place to the right. So C is equal to 31.4, and again, units. And again, it's still just units. I'm only walking around the outside of that circle, starting at one spot and walking all the way around to the spot again. Now here, we have a little bit different. Area is equal to pi r squared, so 3.14 times the radius we said was 5, and the 5 is squared. So this is the part that gets a little tricky. People don't remember to square that 5. It might behoove you to write out 5 times 5 when you do this, if you need to. If you can remember what square is, though, that's great. So area is equal to 3.14 times 25, because 5 times 5 is 25, which gives me 78.5 units squared. Okay, so there is what we're talking about there. We're just squaring those units. Okay, so this is basically all we need to worry about for now. We're just talking about our plane, like I said, polygons, regular geometric figures, including our circle. Make sure you can do the area, perimeter of all of those. Especially, like I said, trapezoid, that's probably one of the harder ones. But keep in mind all of your formulas. That's what you need to make sure you start memorizing. It could be very, one thing I might do for a pop quiz is just ask you for the formula for triangle, formula for a square, to find the area, etc. So you'll need to make sure that, and that would be all it is, not even working anything out, but just telling me what the formulas are. So make sure you have those memorized. Especially, like I said, that trapezoid for area 1. And then, of course, your circle, perimeter, and area. Those are a little bit tricky there, too. Next class, if you have any questions before the next class, please make sure that you email me, and I'll be happy to help you out. I hope you have a great night. See you next class.